Now that we have an understanding of the Boolean type, I want to introduce relational operators. Relational operators compare operands, and that computation will return a Boolean true or false value. In the first column in the table, we have the relational operators. Now some of them are grayed out because we are going to cover them later on in the video. We are going to start off with testing for equality. So we'll start with these two operators, the equality and inequality operators. The equality operator consists of two symbols, two equal symbols or two assignment operators combined. Okay, that forms the equality operator. It is important not to get the equality operator confused with the assignment operator. The equality operator tests for equality, in other words, is the left-hand operand the same as the right-hand operand? If they are equal, or in other words they are the same, then return true, otherwise return false. The next operator is the inequality operator. That also has two symbols, the exclamation symbol followed by the equal symbol. We will learn more about the exclamation in upcoming lectures. That is also used for the logical not operator. Wherever you see the exclamation symbol, it is going to mean not, so in this case it's going to mean not equal to, or in other words the left-hand operand is not the same as the right-hand operand, then return true, otherwise return false. A simple example would be a password where you compare two string literals. If your password matches with whatever is stored in the database, then you get to log in, right? If the two strings do not match, then of course your password is incorrect and you cannot log in. Another example would be the game Hangman, right? If the character that you guess is not part of the character string, or is not in the character string, then one element of that Hangman stick figure is going to get drawn until you lose the game. But if you guess correctly, then of course the character that is guessed correctly will get displayed. That typically makes it easy for the player to guess the other characters right. A quick example on testing for equality using the equality and inequality operators. Here in Visual Studio, I have two booleans, equality and inequality, and I will initialize both of those to false. Notice the convention that I use here. I will provide the variable name with a suffix or a prefix, lower score b, just to say, okay, this is a boolean. That makes it easy for the reader, in other words, some other programmer that comes along that reads your code, to see that, okay, this is a boolean variable. Then I do console output enter an integer for variable x, so I do c and x, and another console output enter an integer for variable y, so I do c and y, and then I'm going to do the test for equality and inequality right here. I'll assign the result of these operations to these variables here to the left. We have the equality operator and the operands are x and y, so we're going to test for equality. If they are equal, then we're going to assign true to the equality boolean variable. Then if they are not equal, so we do the inequality operator, again with x and y as operands. If they are not equal, then we assign true to b inequality. Next, to make the output easy to read, I do the bool alpha flag, so I set the bool alpha flag on the console output stream, as discussed in the previous video. Then I'm going to do console output variable x equals variable y, followed by the equality boolean variable. So if this is true, then it's going to print out true, and then I do cout variable x does not equal variable y, and I do the inequality boolean variable. Pull and run this program. I'll enter something like 3 for x and 3 for y as well. Then we'll get variable x equals variable y, and I also printed out the expression to make it easy to read, so we have the equality operator with the operands x and y, so we get true, and variable x does not equal variable y, that is false. Pull and run that again. I'll enter 5 for x, 4 for y. Now variable x equals variable y is false, and variable x does not equal variable y is true, so inequality is true, equality is false. Right, y does not equal x, 5 does not equal 4, so equality is false, inequality is going to be true. Now, of course, you can do this in fewer statements up here. You can do enter an integer for variable x and y, and then you can do something like this. Cn x and y. And in that case, we'll enter one value, press spacebar, enter another value, and then press enter. But I've decided to do it in this way. One more example, I have the variable x, which is of type int. Now I want to change the variable y to be of type double. Okay, so now I have the variable x, which is of type int, and the variable y, which is of type double. And I want to enter an integer for variable x and a double for variable y. Then I go and do the test for equality and inequality. Build and run that, and I'll enter something like 3 for variable x and some double for variable y. Press enter. we will get variable x equals variable y, that is false, and inequality is going to be true. Build and run again, and I'll enter 5 for both x and y. Now equality will be true and inequality will be false. But there's one interesting case here. Build and run again, and I'll enter something like 5 for variable x. And for variable y, which again is of type double, I'll enter 4, the decimal point, and a bunch of 9s. And I'll press enter. Now all of a sudden we'll get equality is true, inequality is false. That doesn't make sense, right? Because for us these values are not the same. 5 is not the same as 4 point and a bunch of 9s. 5 is basically promoted to a double, and then it is compared with this value right here. The reason why we get equality here, so x equals variable y, true, that has to do with the fact that the computer stores an approximation of that value. Remember that we discussed precision before. Now again, the computer stores an approximation of that value. And as I mentioned in the lesson where I introduced the floating point types, for scientific application you may need scientific libraries. That is, if you need a precision that is beyond what you get with the built-in or fundamental types. Now that really goes beyond our needs, but I just wanted to make you aware of these things and some of the issues that you can run into. One example of a library that you can use when the double type does not provide the precision that you need for an application is the GNU multi-precision arithmetic library. I'm not going to cover this in detail, I'm just showing you this out of interest. But for example, you have a bunch of floating point functions, and the thing here is that the mantissa of each float has a user selectable precision. But of course this is going to be limited by the available memory of the system. At this point I've talked about testing for equality and inequality with the equality and inequality operators. Now we also have the less than operator, the less than or equal to operator, the greater than operator, and the greater than or equal to operator. The less than operator will return true if the left-hand operand is less than the right-hand operand. The less than or equal to operator will return true if the left-hand operand is less than or equal to the right-hand operand. And then the greater than operand will return true if the left-hand operand is greater than the right-hand operand. And of course the greater than or equal to operator will return true if the left-hand operand is greater than or equal to the right-hand operand. I would like to mention that once we've talked about the logical NOT operator in a bit more detail, I will come back to this table and show you a few examples. I will show you expressions that are basically equivalent to the expressions in the example column. But again, many of those will use the logical NOT operator, so we'll have to cover that first, and then I'll come back to this table and show you some additional examples. Back in Visual Studio, I'll clean this example up a bit because we are not going to use these Boolean variables for this example. Now, of course, typically we do want to use variables to store the results of those computations. So here again, we do equality and inequality. We store the results in variables, right? But just to keep the example concise, I'm going to remove this line right here. And I'm going to make y an integer again. And one mistake in the previous example is the string literal had to be enter a double for variable y, not enter and double for variable y. But again, for this subsection, we are going to use integers, so I'll change that back to enter an integer for variable y. And I'm going to use these, so I'm going to cut that out. And I'll delete those lines, so now I can actually build and run this again. Enter two values and this will work fine. But for readability and to make it even more concise, I'm going to make a few more changes here. Okay, and with these statements I can now say, okay, x is equal to y, I can see the actual values. And actually before I run this again, I'll add another string literal right here. That is following the output of the y variable, I'll add a string literal which will contain a colon and a space. And of course following that we are going to print out whatever the results of these computations are, of these expressions. So is x the same as y, or is x not equal to y? Build and run that. Let's just check our output here. So I'll do 55 and 44 for example. And of course the equality is going to be false and inequality is going to be true. Okay, let's go and do similar CR statements for the other relational operators. Okay, something like that should be fine. Build and run that. I'll do 44, for both variable x and y. Press enter and then we get these printouts. So equality is going to be true, inequality is going to be false. 44 is not less than 44, so that's going to be false. 44 is not less than 44, but it is equal to 44. So less than or equal to is going to be true. Greater than is going to be false as well. Again, 44 is equal to 44, so greater than or equal to is going to be true. Build and run once more. Enter something like 55 for x, 44 for y. Equality is going to be false, inequality is going to be true. 55 is not less than 44, so the less than operator will return false. 55 is not less than nor equal to 44, so less than or equal to operator is going to return false. 55 is greater than 44, so the greater than operator is going to return true. 55 is greater than 44 once more, so the greater than or equal to operator is going to return true. And so on. Of course, you can keep testing it in this way. These operators are important. We'll use them to check whether we are within the bounds of a value range or within the bounds of some container that we want to access. We'll cover a few simple examples in this lesson, but in upcoming lessons, we'll talk about containers such as the array, and it's important with an array that you only access an element within that array that actually exists. So in other words, that is not out of bounds. Otherwise, the program will crash, as we'll see in the lesson on arrays. Now that is going to wrap up this video, but in upcoming videos where I demonstrate or introduce the if-else statements, we will be using these relational operators. I'll also be introducing the logical operators, and once we are familiar with those, including the logical not operator, again we'll come back and I'll do a couple more examples on the relational operators for you, again by extending the table that we looked at in this video.